All right, welcome back, guys. Hopefully, there's no technology issues today. Everything seems to be working just fine. Today, we're going to be working on lesson 4.1, which is transformations of functions. So I'm just going to give you the generic equation and kind of tell you what every letter represents. And then you can use this little chart pretty much for, I say pretty much, for every function there is out there. All right, and it kind of goes like this. So we have A f of b times x minus h plus k. So there are four main things that can change a transformation. Now this f part here, that's going to represent all functions. So you could have functions that have a square, a cube, it could have a square root, a cube root, it could just be just a linear function. It could be a logarithmic, it could be a trigonometric function, regardless of what is around these parentheses. Again, it could be a square, a cube, square root, all those different things. It's gonna have the same characteristics. All right, and we'll start off with the A. Try to color code this as best I can. So A, that's going to deal with all your vertical stretching, compression, and reflecting. All right. So first thing it can do is if the A is greater than one, sorry, I should say the absolute value of A is greater than one, it will be what we call a vertical stretch by a factor of A. If the absolute value, remember, so that I can't go less than zero, but if it's between 0 and 1, is what we call a vertical compression by a factor of A. Now, the other thing can do, if A is less than 1, meaning it's a negative, it will reflect across the x-axis. So that's everything that A can do. It does your vertical stretching, compression, and reflection across the x-axis. And then we'll get into B here. B is pretty much everything that A is except horizontally. And anytime you're within the function, it always kind of does the opposite of what you feel like it should do. So let me tell you what that means. This time, if the absolute value of B is greater than 1, it will be a horizontal compression by a factor of 1 over B. So it does everything kind of like what the A does, but in its opposite way. And then if the absolute value of B is between 0 and 1, it will be a horizontal stretch by a factor of 1 over B. So meaning if you are multiplying, if B ends up being like a third, then it's really a stretch by a factor of 1 over a third, which ends up being a 3. And if you are compressing, if B ends up being just 3, and then you're compressing, you end up compressing by a factor of 1/3. So it again does kind of those opposites. Now, if B is less than 1, again meaning negative, it will reflect across the y-axis. Right? Those are probably the two hardest ones. The rest of it, in my opinion, is relatively easy. I say that. There's always tricks, right? So H, basically, if H is less than 0, you're thinking it's going to go left. But again, if it's within the function, if it's less than 0, it will shift right H units, whatever those units might be. And if H is greater than 0, so again, this is meaning negative. This is going to mean positive. This is going to shift left H units. So again, still deals with your vertical or horizontal movement, but this time still doing that opposite. All right, last one is your K. And this one's going to be a normal one, just kind of like A was. If K is greater than 0, it will shift up K units, meaning again positive. And if K is less than 0, meaning negative, it will shift down K units. Now, again, this right here works for every single function. So basically what I want to do for the rest of this video is just go over different types of examples that you could potentially see on the homework. And as always, if there's more examples you need me to do, please reach out. I'm hoping these videos are being very helpful for you as you work through the assignments and start preparing for our first test. All right, so in this, again, all this will come out of the textbook, but we will look at number 2, and it says f of x equals 1 over x minus 4 plus 5. Now, your homework has a variety of questions. Some of the questions are as easy as, what is the base function? So we'll start there. What is the base function? And basically what that means is, what's the parent function? If you took away all the transformations, what would be left? And really, that's what you do. Take away all of these numbers. Take away the -5, the -4, and the 5. If you took away this 1, then you wouldn't have a function anymore. So the 1 needs to still be there. But this -4 and this 5 doesn't. So the parent function here would just be 1 over x. That's the base function. Then I think it wants you to describe what that graph would look like. So going back from the 3-6 video, 1 over x basically has the branches where you're in the first quadrant and in the third quadrant. So that's what the parent function is. So that's kind of like some of the questions are going to ask. What's the base function? What's that look like? And then that you move on. Some questions might also ask, what would be the transformation? So this -4 here, it is within the function. So this is going to be, let's see, this would be your, what, I think that's K, right? Yeah, no, H. Is that the H inside? Okay, cool. So this right here would be your H, which is, again, what's inside this fraction, where the outside over here, that's going to be your K. So when you have to describe the transformation on some of those questions, you would say, all right, well, H deals with left and right. It's a -4. I do the opposite of what I think. So this would be, it shifts 4 units to the right. Again, you want to say left, but it does the opposite, so you go right. And then the K there, you say, well, it also shifts 5 units up. Right? And then that's it. So that's your description. And then some are going to want you to actually graph it. Looking at the graphs is not too bad. They start you off with like the parent function, and then they just kind of have you just change things around. So if we had to graph this right here, we haven't gotten to it, but something you should have maybe heard before are called asymptotes, which are these imaginary lines in which these branches don't cross. And so when you are doing these transformations, you're moving these asymptotes so that the branches move with it. So I want to move this first vertical asymptote right 4 units. I'm going to go 1, 2, 3, 4. And if it helps, put a dotted line. Now on the homework, it's not going to have a dotted line, so you'll just kind of move that invisible dot there that they'll have for you. And then on this horizontal asymptote, it went up 5 units. 1, 2, 3, 4. Okay. Oh my gosh. This is going to be a poor drawing because where it fell. And then the branches would just go still in their corresponding area. But now notice they're basically both in quadrant 1. So this starts you off, but this is changing those asymptotes. So those are pretty much like all the type of questions it could ask you. It could ask you all those questions. I think there's another type of question. Let me see. I wrote it down. Yeah. It might also ask, so third thing it might ask is to graph it, which again is just going to have you shift the parent function. But the fourth and final thing I saw it ask was, what's the domain and range? All right, domain, remember, are the X values and the range is the Y values. So with these type of functions, the domain is going to be everything except that vertical asymptote, which in this case is a +4. So the way you would write that is you go negative infinity, 4, union, 4 to infinity. All right, so again, 4 has the parentheses. I think we talked about this in the chapter 1 and 2 review videos. And then it's not a bracket because it's not included, but basically it's representing everything but the 4. And the range, same concept, but this time with the horizontal asymptote. So in this case, it would be negative infinity to 5, union 5 to infinity. Right? Now I know question 1 on the book didn't ask all these questions, but I wanted to make sure I kind of highlighted everything so you had examples. All right, but let's do some more examples. Let's look at number 5. This one is f of x equals the square root of x plus 2 minus 5. Now, I'm not going to rewrite all of these questions. I'm just going to label them as 1, 2, 3, and 4. And then you can go back to the previous question to figure out what that is, but I'll say it out loud as well. Number 1 was, what is the base function? So again, if you eliminated all the numbers, what is left? And hopefully you see that it's just the square root of x function. The parent function of that, if you recall from the video 3.6, does this right here. All right? So that's the beginning. Then 2, you'll describe the transformation. So this is my h, this is my k. So that means I shift 2 units to the left. Again, it's going to do the opposite of what you think. And it shifts 5 units down. The k does what you think. I almost forgot all the questions. Third one, now graph it. So again, it's going to have a dot like right here, and you're just going to move that around. So that's what I'm going to do. I'm going to take this 0, 0 coordinate, and I'm going to do this shift. So I'm going to go left 2, and then down 5. And then I'm going to sketch the rest of the graph, give or take. All right, so that is what a new graph could look like. It's not asking for like intercepts right now. We'll get further into detail throughout the rest of this chapter. All right, and then the fourth thing was domain and range. So the domain, I can see that it's going to be my x values, and I see it looks like it goes from -2 on to infinity. Infinity will always get a parentheses, but this is a solid dot that I put there. So that would be a bracket. Now you might be asking, well, how do you know it's going to be a solid dot? Well, plug in -2 into the function. -2 plus 2 is 0. Square root of 0 is 0. And then I got -5. So I got an actual value. Notice if I was to plug in -3, -3 plus 2 is -1. I do not have a real square root of a negative number. So therefore, it would not be part of it. So that's kind of how you can check it. Your range goes from bottom to top. So it goes all the way down to -5 and then goes all the way up. Oh, that's a bad infinity sound. Let's try that again. So that gives you a bracket. So remember, domain, left to right, range, bottom to top, least to greatest, basically. All right, let's look at some more while we got some time. So we'll look at number 6. And this is f of x equals the step function of -2 minus x as such. So number 1, the base function here. If I took out all the signs and the numbers, I'd be left with the step function x. And if you recall, it was basically, I think this was actually called the greatest integer, but also known as a step function to most mathematicians. You know what I said that was in 3.6. It's actually 3.4 where all these graphs are. Let's make sure I got them in the right spots. So it'll be like this. Only make it big to kind of clarify there. But that's kind of base what it would look like. And then we're going to describe. So we actually have this right here. It's inside the function. So that whole thing is an H. And then this right here is actually going to be my B. All right. So I see B is less than 0, meaning it's a negative. So I'm going to have a reflection. But because it's inside the function, it's going to be a horizontal reflection. So that means horizontally, it has to reflect across the x-axis. So if this is the horizontal axis and it's going to reflect horizontally, notice my pen is staying on the x-axis, but it's rotating around the y-axis. So this will be a reflection across the y-axis. And then my h would just be a shift right, because again, that's the opposite, 2 units. Right? The third thing is then to graph that. So again, I'm going to take one of these steps. I'm going to reflect it across the y-axis. And then I'm also going to shift it right too. So maybe I should do that first. Let's take this point right here. I'll go right 2. Which would then be a solid dot, and then reflect it would still be a solid dot, but now the open dot is on the left rather than on the right. So I shifted it 2 units, and instead of extending it that way, I then had to extend it this way. So then it kind of follows the same pattern. So this would be as such. There you go. Nope. And then the fourth thing is domain and range. Domain looks like it hits every value. So it looks like it's not connected, but the domain actually does hit every value. So this would be -infinity to infinity. There is some value. Your range, I wonder if they gave an example of one. They did. All right. So with the range, it's technically all these integers. So what they said is you could technically write it like this, which is the entire integer family. And this one could also be written as all real numbers. So domain is every real number, range is every integer. So you could write it like that if asked. I don't know if it gets that in depth in the homework. All right, another one would be number 7. So we look at f of x equals 1 over x plus 2 squared plus 1. So let's kind of go through the process. So the parent function, again, I would take out all numbers and signs. Now this is a symbol, this is a square, so that's going to be part of that original function, not a number. So this would be f of x equals 1 over x squared, because that's what would be left if you took out all the numbers. All right, so then if you recall from 3.4, not 3.6, the branches were like this, right? Because it never gave you a negative value. It would just be squared, so just be on the other side. All right, number 2, again, what we're going to do is this 2 right here will represent my h because it's within the function, and my 1 right here would be my k because it's outside the function. So therefore, I shift 2 units left. Always do the opposite when you're inside the function, and then shifts 1 unit up. It does what it does what you expect it to do. 3 asks you then to graph it. So just like in the previous one, there's like an imaginary asymptotes here on the x and y axis, and I'm going to shift those up, or I'm going to shift those asymptotes, and the branches will get moved with it. So this says shift 2 units to the left, so I'm going to shift this vertical axis 2 units to the left. This horizontal shift, I'll shift up 1 unit. And then the branches are still going to kind of be in the same area, but now we're not dependent on quadrant as much as we're dependent on those new asymptotes. And then just like before, oh, that's an A. The domain and range is going to be all real numbers except for the vertical asymptote. So that's going to be negative infinity to -2 union -2 to infinity. The range would be everything but the horizontal asymptotes. That'd be negative infinity to 1 union 1 to infinity. Again, it's not going to ask all of these questions. I'm just trying to give a good review for all types. All right, that was number 7. All right, let's look at number 9. So we get f of x equals x plus 6 cubed. So again, base function, everything but the number. So take out the 6. Notice the cube is a symbol, not a number. So this would just be x cubed. The parent function for that one looks a little bit like this. Let me do a little better than that. Yeah, goes through the origin there, it curves like that. A little bit harder to draw. All right, second thing, describe the transformations. So again, this right here would be my H. So I would shift left, because you always do the opposite, 6 units. Third thing, actually graph it. So what I'm going to do is I'm going to take this, it crosses the origin. So that's what I'm going to move. So I'm going to go left 6. So 1, 2, 3, 4, 5, 6. So that's about right there. So then when I graph it, I'm going to graph it like this. So basically it's the same shape. Now further in these units, we'll get more definite on how to graph this exact. Right now we're just kind of sketching what it would look like due to the transformation. 4, your domain and range would be all real numbers for all cubic functions, and it's really for all polynomial functions, which are basically like your linear, your quadratics, your cubics, your fourth power, your fifth power. All of those are always going to be all real numbers for both the domain and range. That will come into play later, just knowing that fact. All right, so the next question I want to look at is number 18. This is P of X equals negative X plus 1 squared plus 2. All right, so this right here is considered to be my A. This right here is my H. This right here is my K, and I totally got ahead of myself. The base function here, if you take out all these numbers and signs, and you're left with just the letter and the symbols, this is just going to be x squared, which is a quadratic, which makes a parabola. Now we can describe all these. So since A is just a negative, that deals with a reflection. So that would be a reflection. And because it's on the outside of the function and not inside, it would be across the x-axis. And then the h shifts 1 unit left because it does the opposite inside the function. And then the 2 there, it shifts 2 units up because it does what you think. So then if we had to sketch this, I'm going to use the origin, and that's what I'm going to move. So I'm going 1 unit left, 2 units up. This reflection, think about what the reflection would look like with just a reflection, and you would see that it would reflect down here. So when I graph this, I'm going to make that same type of graph go downwards. Now, again, we're not trying to be specific because, again, it's on a program, so you'll be able to plug it in exactly. And the last thing here, domain and range. This is a polynomial function because it's a quadratic. It's a power function, basically. The domain and range are all real numbers every single time. All right, look at this a few more. Gonna try and give you a good example of everything. Let's look at number 24, which says W of X equals 1 over X minus 3 squared. I think we did one like this already. It's all right, though. So the parent function of this one would be 1 over X squared because, again, if you eliminate the numbers, keep the symbols, can't delete that 1, and that's what you're left with. It looks like this. This right here would be my H. So that means this shifts, almost but left, shifts right 3 units. Again, if it's inside the function, it does the opposite. So it shifts right 3 units. So the only thing that's going to be changed on these asymptotes is this vertical asymptote. So I'm going to go right 1, 2, 3. And then the vertical or horizontal asymptote is going to stay the same. So therefore, my graphs will look something like this. Oh, this is 3. 4 would be domain and range. Again, domain is everything except the vertical asymptote. So in this case, that's negative infinity to 3 union 3 to infinity. Range is going to be everything but that horizontal asymptote that didn't move. So that'd be negative infinity to 0 union 0 to infinity. Alrighty. Hopefully it's getting easier. So let's look at number 37. So look at v of x equals negative 3 square root of x minus 1 plus 2. So first thing, parent function, obviously if you get rid of all the numbers, hopefully you see it pretty easily. It's just the square root of x. And that function again looks like this. In this case, this right here would be my a, h, and k. So notice that every different function I've had, I was able to go right back to that very first slide of that parent function because they're all the same. They're all described the same way. So my a, it's less than 0, so it's a negative. So that means we have a reflection. And because it's outside the function, this will be across the x-axis. Now, if we look at it as the absolute value of 3, then that means that it is greater than 1, so that's going to be a vertical stretch. So it does what you think because it's on the outside of the function by a factor of 3. It's going to be the absolute value of it. All right, and then this -1 here, that's going to be a shifts right 1 unit, and then shifts up 2 units. So to graph that, I start with that point right there, and I'm going to go right 1, up 2. So that's where my first point's going to go. And then it's a reflection across the x-axis. So that means it's going to be flipped down, but also stretched vertically. So that means it's going to probably be a little bit longer than normal. If you really wanted a good indicator of where that would be, the second point here would be 1, 1, because the square root of 1 is 1. So that just means that you would go over 1, but in this case down 1, 2, 3. So we kind of roughly got there. And then the next thing would be the next stretch. So the next one would be like 4 would be 2, but this time 4 would be 6. So I'd go 3, 4, and then 1, 2, well, 1, 2, 3, 4, 5, 6. So it'd be probably more here, stretched out. Right? Or I say it's, hold on, it's going to be really vertically stretched. So it's going to be more like that because it's going to get further and further out. Right. And so, but you don't have to be that defined on the homework. You're literally just going to be moving points around. So we won't get to, that's just getting ahead of myself. All right. So the domain again is going to be the X, so left to right. So the farthest it goes is 1, but it's included up to infinity. And then the range is bottom to top. So bottom wise, I have negative infinity, but my top stops at 2 and is included in the set. Alrighty, just a couple more. There's another type of question you'll get like 55. I'm not going to write it word for word, but I'll put all the basic stuff in there. So it says use the function g of x equals the square root of x, and then sketch the function horizontally by a factor of 2. So horizontally stretching deals with my b. So let's run it like that. So horizontal stretch deals with my b. And it says by a factor of 2. All right, so if I want a horizontal stretch by a factor of 2, remember with our horizontal stretching, it was like 1 over b. So it's really going to be like this. And so therefore, when I plug in the factor, it becomes 1 over 2. So that's my horizontal stretch. But then it also says a reflection with respect to the y-axis, so across the y-axis. And again, if you go back to that first slide for notes, that deals also with the b. So that means my b is going to be less than 0. So now I'm just kind of writing notes as I go. My b in this case would basically be now -1/2. All right. So it takes the previous work and then now it reflects it. And then it also says and moves 3 units up. All right. If we're dealing with up, that's my k, and it's just going to be the straight value. So it's a +3. So when we write all this out, this becomes g of x. And it's going to be the square root, so there's no a. Then I have my b, which is -1, and then my x, and then there's no k, so I made that way too big. I mean, sorry, there's no h, and then +3. So remember, all this stems from that a f of b x minus h plus k. I had a b and I had a k. So there was no a, so there's no number here, no h, so there's no other numbers in the parentheses, and now I have it. All right, last topic question I did see on the homework is you are given a graph, and I'm going to try my best. I know I didn't copy and paste it like I normally do. So 1, 2, 3, and then 1. All right, so a couple things you need to go is you kind of need to know what's the base function of this. And you should notice this shape is more like a cubic function. But remember, a cubic parent function goes like this. So on 2, if you're trying to describe the transformation, now cubics are, it can kind of go both ways here. This could be a horizontal reflection, because you could just flip it like that, but it could also be a vertical reflection. So I think I'm going to go with a reflection across the x-axis. But with a cubic, if you put a negative on the outside or the inside, you'll actually get the same answer. So this could go either way here. So reflection across x-axis, but you could do either or, and you should get an answer correct for both. And then I also see it move. So I see it shifted 3 units right and 1 unit up. So if I'm trying to build an equation, I can go, all right, this is going to be f of x. This reflection across the x-axis is going to make my a negative. So it's going to be less than 0. This is my h, and because I went right, I'll actually go -3. That's the only way I can go right. And then up would just be that k is equal to 1. So again, stemming from this main function here, I can write out my equation. So I have an a that's less than 0, but nothing other than that. So it's just going to be a negative. And then I have parentheses k, or sorry, not k, x. I don't have a b, but I do have an h. It's going to be a -3. So it's not going to be a -3. It's just going to be -3. Because again, if I relook at that, I go, all right, that's going to tell me I'm going to go right. So that's how you want to kind of look at that. And if it's too confusing, you can just say, all right, well, h is 3, and I plug it into that formula. So it's just straight up 3. So maybe that would be a better interpretation. So that deals with my h. So when I plug it in, I get a -3. It's just how my brain works, but maybe that will be a little bit easier. This is a cubic function. So the cube will go right here. And then my plus k is just a +1. And then there you go. You have your function. I think that's as far as it goes. Is asked for like more details on that one. So use your knowledge about transformation, find the possible. Yeah, this. If it did do domain and range, just to keep consistent with all of our problems. Remember, it's a polynomial function, so the domain and range is all real numbers. And that's pretty much all of 4.1. In 4.2, we'll get into properties of functions, but that will be for the next video. Again, hopefully you are enjoying the class and are getting a lot out of it. Again, if you ever struggle, please reach out. Until next video, see you then.